How's it going, everybody, and welcome back to another 1001 MSc online tutorial. My name is Brock Grant, and today we're going to venture into the world of physics. So we're going to be looking at kinematics in one dimension. So a couple of things we're going to be looking at here. We're going to try and break it down as far as we can in terms of looking at distance, speed, velocity, and how they differ between them and when it's appropriate to use one or the other. Now, a big thing here I recommend is that if math is not your strong suit, to please go through and refresh on your math skills. Okay, so large emphasis on this is on rearranging mathematical equations and being able to convert units and solve. Now, I want to give a quick textbook warning here. So be aware of the following things in regards to using your textbook for physics. The first thing is that the entire physics section will be using textbook number 2. So that's this one, okay? So don't try and go through your textbook 1, the chemistry round, and go, I can't find any of the physics stuff, okay? Because they're all in here. The next thing too is that the answers can be found on Learning at Griffith. Now, we are not providing you the full solutions, but we are going to be giving you the answer so you can check whether you're right or wrong. Now, if you do have any difficulties or anything like that, feel free to join us on the Facebook page, or you can use the discussion board on Learning at Griffith. Now, one last thing is that the textbook questions are tough, okay? They're bloody difficult. Now, what I want you to do is, if you have attempted the textbook questions over here, and you found them very overwhelming, you found them exceptionally difficult, attempt the lecture questions first. Okay, so do the lecture questions. These will be found in your actual lecture book. Go through those ones. Get your sort of put a foot in the water, see how you're going, then move forward to the textbook one. Do the textbook questions, and if you're feeling comfortable with those, then move on to the challenge questions. Okay? Now, one last thing is that certain values or certain equations will be provided for you in the exam. So that's good news. I will make note of those during these videos for you so that you know which things you will need to memorize and which things will be given to you in your exam. Okay, so let's push on into it. So let's look now at distance versus displacement. Now, the whole thing of kinematics, this entire module, is essentially describing motion without reference to any forces. Okay, so that may sound a bit strange, but don't worry, it'll become apparent in a moment. So essentially, what we're going to be looking at here is we're looking at distance and displacement. Now, these are different things, and you need to be very careful on which one you use. Now, the distance is the length of a path that is taken by an object, whereas displacement is the difference between the final and the initial position of a certain object or person that is being traveled. So a good way to look at it is the use of this diagram here. So we can see that we have 3 different paths. So we've got path 1 sort of doing a real sort of squiggly motion, traveling around, and path 3 is sort of going a bit roundabouts, but is still getting to path B. These ones here, that is distance, okay? Because that is showing the actual path, like how far they traveled. Whereas displacement is the raw distance between the initial and final starting place. So it's very sort of linear. And these two differences here is a great opportunity to show the difference between a scalar and a vector. So distance is a scalar quantity. So essentially it describes the magnitude, so how much or how high a particular value is, but it does not give a direction. So a good example here is temperature. So we don't sort of go, oh, I have 400 Kelvin south. Or, you know, I'm traveling upwards at 600 degrees Celsius, okay? It doesn't really work because that's a scalar quantity. So it gives you the magnitude. It lets you know how much of it you have, but it doesn't say a particular direction. whereas a vector will give magnitude, so how much, and direction. So a good example here is like acceleration. So we could say that a car was accelerating east, okay, at 5 meters per second squared, or 10 meters per second squared. Or you could say it was decelerating, so it was moving the other way. We can give direction to these particular values. Okay, and I'm going to be covering that a little bit more as we move forward through these modules. Now, in order for us to describe the motion of an object, so in order for us to accurately give the reader information on how something is moving, we need to be aware of where it is at all times. So we need to know where it started, where it's finished, and what's going on. So, for example, if we look at displacement, so remember, displacement is the difference between where an object started and where an object finished. And displacement is denoted as x. So when we look at displacement, we look at where the object finished. So for example, if we had, so he started at 0 meters, because that's his starting point, and he finished all the way over here at 5 meters, what was his displacement? Okay, so we take the initial position, which is xo. This can also be written as xi. There are many different ways that it can be written. It can also, which is something I should note in your textbooks, sometimes displacement can also be noted as s. Okay, so don't worry about that. It's one of those things, I'm afraid, with science. It's just they're noted as different letters. You can use whichever one you like. You can choose to use S like they do in the textbook. You can choose to use X like I do. The big thing is just that as long as you understand what that letter means, everything's all good. So we can go XO, which is our initial, and we go final position, which is X. So we go our final position minus our initial. So we could see here that the total displacement was 5 meters. Now we can show this 5 meters as delta x. Now, if we had our example here, but we said he moved this way, okay, and he ran this way for 10 meters. This means that if he started here and ran over here, his displacement would be, so his initial position was 0 meters. His final position was negative 10 meters. Therefore, his change in displacement was negative 10 meters. So I may hear you say, well, hang on, what's the deal with the negative and the positive? That negative simply represents that he went in the opposite direction. So because he went backwards, I said that was moving in a negative direction. Whereas if he had have gone forwards, that was a positive direction. So this goes back to what we were talking about with vectors, how displacement has a unit of magnitude and direction. Now let us look at speed and velocity, because that is the same as like when we were comparing distance and displacement. Comparing speed and velocity is very similar because speed is a scalar quantity. Okay, so it just refers to how fast an object is moving. So when we can see this by speed is equal to distance over time. So this formula here you will need to memorize. So speed is the scalar quantity. So we just say something is moving at this speed, but we don't say a direction. Whereas velocity is a little bit different. So velocity is a vector, and it doesn't tell you how fast an object is moving. It tells you the rate that an object changes its position. So although they may sound one and the same, they are very different. So this tells us how quickly is this particular object changing its overall position. So tell you what, let's have a look at a quick example here just to help concrete it into our minds. So if we have a runner and it ran around the circumference of a circular track that was 2 kilometers. So it took the runner about an hour to complete the track. So what was the runner's speed and the runner's velocity? So the big thing here is we look at the circumference of our track. So here we have our running track and our start/finish line. So we have our happy runner here, and he's ready to take off. So this entire track, all the way around here, has a distance that is 2 kilometers. So if we look at the runner, how long it took him, so it took him an hour. So we can use the formula speed is equal to distance over time, which means the runner's speed was 2 kilometers over 1 hour. So that means that his total speed was 2 kilometers an hour. But now let us look at what the velocity would be. So the velocity is equal to the displacement over time. So what is our person's displacement? So we take the final position and we subtract it by the initial position. So if this runner does a complete lap around this circuit and he finishes and he stops right at the finish line, his displacement is 0. Why? Because his initial starting place is the same as his final starting place. So technically, if you look at his displacement, he didn't actually move because his final position is not different to his initial position. So it means that he moved 0 meters in 1 hour, which means his total velocity is 0 meters per hour. Or if we use the proper units, 0 meters per second. So this is how speed and velocity are very, very different. Okay, and that's how it can be a little bit tricky to distinguish between the two. So just ask yourself, if it's looking for raw speed, that's fine, because distance will always be a positive value. Displacement and velocity, however, because they're vectors, that can be a little bit different because they can have positive and negative values based on their direction. So here we have some kinematic formulas. So these equations are used to describe the motion of an object that is at a constant acceleration. So don't worry, we're not going to get any more complicated than that. That's for future studies. Now, before we push on, stop panicking, okay? Don't panic about these equations because they will be given to you in your exam. So that's A-okay. So these will be provided. But a tale of caution. I want you to be very careful. Yes, these equations will be given to you. So it means you don't have to rote learn and memorize them. But, and there's a big but, you still need to understand how to use them. Okay? Treat these equations as if they're telling you a story. What does it mean? What are they trying to tell you? Because if you don't understand that, then you can get the question wrong. And that is a big student trap that students fall into. They don't bother looking into these equations and knowing how they work because they just assume because they're given it on the exam that everything's hunky-dory. However, if you don't understand when, why, and how to use these equations, you won't get the questions right. So now that we've covered distance, displacement, velocity, and speed, let us now have a look at acceleration. So acceleration describes the rate. So it describes how quickly, or indeed how slowly, the velocity, okay? Now that's a big thing too. The velocity changes in accordance with time. Now, acceleration can be a negative value. So this is referred to as deceleration, okay? Because it's accelerating in the opposite direction to the velocity. Now, this is the formula for acceleration. There will be a few more, especially in the subsequent modules. However, this one describes how acceleration works. So we've got the change in velocity by the change in time. So this gives us the units of meters per second squared. So to summarize, so speed is equal to distance over time. So velocity is displacement over time. So velocity will typically have the units of meters per second. And acceleration is the change in velocity over time, and that is meters per second squared. So the same sort of logic that I applied with chemistry about being able to connect all of the equations together, that same rule applies with kinematics. So be able to connect the dots, be able to see, oh, if we're given the velocity and we know the displacement, we can use time and then we can use the change in time, blah, blah, blah. This is what I meant too by looking at those kinematic equations, being able to understand them, because that is the key with this module, is being able to understand how they all link together, why you need to use that equation, or how you could use that equation to solve the question. And I'm going to make a high emphasis on that in the next video when we go through and we solve a few questions. So we've focused quite a bit on looking at the on the x-axis. So we're looking at a lot of movement and motion this way. But what happens if we've got motion going up and down? So this is where we're going to be talking about free fall and gravity. So as we know, we all are feeling the effect or the force of gravity. So gravity is what makes objects fall down to the ground with a particular speed. Now, the acceleration that is caused by gravity is 9.8 meters per second squared. And this absolutely must be memorized, okay? You must know that the acceleration due to gravity is 9.8 meters per second squared. No ifs, buts, or maybes. You need that one. Now, a quick thing to note too is that this is in the case where we ignore air resistance. So most questions that you're going to get in this course will be running under the assumption that we're going to neglect air resistance, because otherwise it just gets way too complicated. So don't get bogged down too much in the hard details like that, because you won't need it. Now, a big thing to note too, again, it's sort of a bit of a discrepancy I've noticed in your textbooks, is that when we look at displacement, we denote it as x, because it's the change on the x-axis. However, some textbooks refer to it as y. So if we look at a graph, you have x that goes this way, but if you have a graph that goes up, that's denoted as y. So not to worry about that, there's no need to get too worried. All it means is that it's still displacement, but it just means instead of moving left to right, it's just moving up and down. Okay, so that now finishes off Module 12 Video 1. Thank you all very much for watching today. I hope you all enjoyed it. If you do have any feedback or suggestions, please feel free to hit me up at b.grant@griffith.edu.au. Also, please don't forget the survey down there. I know I say it all the time, but it really, really does help. I've noticed that a lot of you are doing those surveys, so thank you very much for doing that. I really do appreciate it. So thank you all very much for joining me today. Keep up the hard work, guys, and I'll see you all next time.